All right, Yuval, you want to introduce the topic?
Yeah. So this came as part of the end-to-end tracing PR, but I mean the topic is more general. So the thing in end-to-end tracing is that tracing itself is not radar specific. I mean the traces and everything they could be used anywhere, um, but they need to be used in the end-to-end tracing PR. There's somewhere in the code that they need to be passed through the different Redis APIs and eventually being serialized into the messages. So there has to be some Redis code that that knows about tracing. Um, now, uh, this work that Omri did, and what he did is that he added the trace to the cell object because kind of the object can hold a trace and accumulate all kind of things and information to the trace, and eventually the object goes into Redis, and you can take the trace, serialize that, and send it over. Now, as part of a recent refactoring work that Casey did, he kind of removed calls to the cell layer from Redis, which makes sense because Redis is a specific implementation of cell. And I mean, why a specific implementation need to touch the generic APIs that it implements, right? It doesn't need to because it just implements them. So this makes sense, but um, I ran here into an issue with the fact that um, I need to touch something that exists only in cell because it's not Redis specific, but I need to touch that and access that from within Redis. Now, uh, kind of wondering what would be the approach in a specific case and maybe in a more generic way. So specifically, I can solve that in all kind of ways. For example, I can do whatever we did with the logging, like with the DPP, and just add the trace to all the APIs, all the function definitions, and let it kind of trickle through all the function calls until it's being used somewhere in the Redis call. Uh, I mean, this is going to be a major change to many functions, uh, and to be honest, I do think that it could make sense to have a trace as an attribute or a member of the object. So there are kind of two reasons for me for not to do that. Not only that it's going to be a huge amount of work, but also um, I think a trace could be a member of the object. Um, so in this case, I'm not sure what would be kind of the right approach here. Like, do we have an equivalent to a cell object that lives in the Redis implementation that we can just move the trace there, and or maybe do take some different approach?
Right, so there's the RGW cell Rados, which has a derived class Rados object, which would have access to that trace, but the issue is passing it from that into all of the RGW Rados code so that it can link up with our calls into librados, right?
Mhm. Okay, so there is a Redis object that derives from a cell object that has the trace already.
Correct, yeah.
Okay. So that's probably going to be the best kind of way, right? I need to figure out how to access that from kind of. I mean, inside the libRedis code itself, we don't expect anything with the object or anything. It's just that we pass a trace there. So when I kind of reach the libRedis layer, then I just pass the trace. But to get this um, from the cell layer through our Rados kind of code to liberate us, I would need to somehow pass the Rados object.
So I guess you mentioned RGW obj, a struct which just has the bucket and the object name, but RGW Rados does also have some nested classes like bucket and object.
Okay.
So you could potentially thread the trace through each of those structs
Yeah,
and make it
I
accessible to all the functions on them, but that wouldn't cover everything. But I
well,
think it would be a good step.
okay. So I'll probably try to do that. I mean, the reason I mentioned RGW obj because I mean, the code kind of broke without any kind of merge conflict, but there actually kind of it just doesn't compile after the rebase because like we kept the same name. So there's something called an object, and in the before the refactoring, the object was a Sal object. So if I was doing object dot get trace, then I would just get a trace. And now it's still object in the code, but it doesn't have a get trace function because object is just an RGW object. So as you said, it's just a name. Um, so I guess it's not like everywhere in the code where we had a cell object, it was replaced with a Rados object. Like in many cases, it was just replaced with a simpler struct that just has the name in the bucket.
That's right. Yeah, the PR did make some modifications to those nested classes like the bucket and object though also.
Mhm. So my question is, um, would it make sense to pass both the RGW object and the Redis object, or maybe just pass the Redis object, assuming that it holds the RGW object as a member?
I mean, I feel like the RGW Rados layer shouldn't deal with Sal objects at all, not even Rados objects, because it does a lot of things where it would have to like construct or fake up a Rados object just to name something. Most of RGW Rados's implementation is just it takes an object name and does an operation on it instead of carrying around a lot of associated state like Sal objects do.
Hmm.
So
I
I
mean,
don't think that we want to mix the layers like that. I think it's a good property of RGW Rados that it only needs to know object names.
okay, so although I mean that makes sense if RGW Redis needs to, I mean, can live in an environment where there's no cell. I mean, this is the intent, then this makes sense. If not, then RGW object is a Redis specific implementation of something. It's not something. It's not like it doesn't break the layering if RGW Redis use it because RGW Redis is the implementation. I mean, does the RGW Redis class doesn't inherit from like the cell driver or something, anyways, or is it completely separated?
It's completely separated. There's
Mhm.
a Rados driver or a Rados store that inherits from the Sal thing, but that's in RGW Sal Rados. I think I think
Okay,
I think that Rados store owns as a member a class of RGW Rados.
I see. Okay, so RGW Redis is completely standalone. It can work where there's no cell abstraction at all.
Right.
I mean,
And
not currently, because when I did the original Sal work, stuff got threaded into it. I mean, in case you took a bunch of that out, but I think there's still some in there.
No, okay, but the intent is to clean it up completely. So if I'm, let's say, in theory, building an RGW that supports only Raiders, then I can do that. In theory.
I mean, there would be no front end for it.
Yeah, let's say I'm using LibRaiders or something. LibRGW, sorry.
No, LibRGW uses Sal.
Mm-hmm.
So all the front ends use Sal. So you could take the RGW Rados implementation, pull it out, and write something else on top of it.
I see. Okay.
But nothing else exists on top of it other than Sal.
But in theory, that could be done once we finish up to do the complete cleanup, and then it could be a standalone.
Presumably, yeah.
Yeah. Okay.
Yeah, I don't think we have a real use case for that, but maybe it would help if I talk about some of the motivation for my changes in RGW Rados recently.
Okay.
I'm linking a separate PR into the agenda 50148. And this is the ability to send a head or get object request for a single part of a multi-part upload. And so in the Rados implementation of this, we need to do operations on like a single part, not something that's represented by a cell object. And we can name parts with RGW obj, but they don't make sense as a full Rados object, or sorry, a full cell object. So to implement this, I needed the ability to kind of avoid creating things as real cell objects, but still do read operations on a specific part. So I think it's really useful to keep RGW Rados just in terms of object names so that it can be flexible like this and not mix in kind of the higher level concepts that we have in Sal.
So that brings us back then to we have to thread a trace object the same way we did DPP and yield. And it's got to be threaded everywhere because there's no place you can tack it on that already exists.
Well, the RGW Rados subclasses for object and bucket, which the read and write operations go through, would be a good place to stash a trace that at least the reads and writes would have access to. But you're right that there's a lot of functions in RGW Rados that aren't related to those classes and would need to be threaded. But I forget exactly what tracing coverage we get from the end-to-end tracing PR. Maybe just the read and write objects would cover everything that we have in there.
I mean, I can look again at the code, but eventually, I mean, without adding that to the object, I remember that was extremely difficult to do that because it wasn't like a straightforward kind of like a stack of functions calling one another. I can look at that again, but at least this is what Omri said, that without putting that into the object, that's going to be quite difficult. But I mean, I guess it should be possible. It's all function code. Like there's nowhere in the code that we store object like in a container, right?
There's a RGW Rados : object class. And looking at this tracing PR, the only change to RGW Rados CC is a derived, or it only changes RGW Rados object do write meta.
Okay.
So if you put a trace in RGW Rados object, you could access it from this do write meta function.
Okay.
So I think that that approach would cover everything in this PR.
Mhm.
But as we wanted to extend the coverage of tracing, we would
Yeah.
have to do the threading.
Right. I mean, the PR was just to do like the most basic implementation or the most basic functionality, just to show that it can work and you can have a trace that is RGW and OSD together. But it was really, from functionality perspective, it's very limited. The whole idea was just to demonstrate that this is possible and working.
Yeah, but I do think that adding a trace to that object class would get a lot of coverage, at least for the read and write paths, which are probably the most important.
Right. And this class is being constructed from RGW Redis cell, right? So, or anywhere from the front end.
Yes.
Right. Okay.
Yeah, the pattern generally is that you construct one of these RGW Rados object things, and then you construct a RGW Rados operation using that object as the target.
Mm-hmm. Okay.
Yeah, so the biggest users of this for your case would be the cell object read op subclass, and then the writers. There are a few other places in RGW Rados in the Rados store that use this behind the scenes.
Okay. Yeah, I'll have a look. I mean, I'll see if this is sufficient, then I'll just do that. And later on, if we want to trace more things, then we figure out other places.
Sounds good.
Okay, thank you.
Any other thoughts on this? All right, we got Ali now. You want to talk about RGW user create CR?
Yeah, this is pretty quick. I forgot I even put this on the agenda. I remember in the keys cap PR, that CR, one of the functions in that class was calling, I think it was user creation, via the admin API, and you mentioned that that class doesn't get called by anybody and it should be removed. I was wondering how trivial removing that class would be, and if there's anything else along those lines that would need to be removed. I think you also mentioned it had something to do with PubSub, so it's not used anymore.
That's right. Yeah, it was a dependency of the PubSub stuff that you've all recently removed, and it has no collars anymore. There might be other classes in that same file that are unused also, but I didn't grep for them.
Okay. So if I spend a little bit of time removing that class and maybe a few others in that file, would it be as simple as making sure there's no callers, deleting it, and making sure the code compiles?
Yep.
Okay.
And
Well,
I mean, in general, I would say in terms of your key cap PR, just delete this one. And if we find ourselves having to make changes to other classes in there, we can investigate whether they're still used.
yeah. No, I was kind of trying to bring up that larger topic because I didn't know if this was the tip of the iceberg and stuff that was left over that needed to be deleted, or if it was just this one.
Yeah, it's hard to tell, but I think I just want to avoid us having to maintain stuff that's not used. And so as we find ourselves having to make changes to the dark corners of RGW, we could also look into who their callers are, and if we find there are none, we can remove it.
Okay. And yeah, I don't mean to. There's no overlap in my mind in terms of the adding cat PR in this. Yeah, maybe I'll go about and delete that class and poke around a little more and see what the other classes are in that file, and at least open up a PR for deleting that one.
Sure.
I also wasn't sure if Yuval was the one that originally wrote that as part of the pub sub stuff, or it was from there before, or what the
Yeah,
history was.
that was from Yehuda's first draft of PubSub as a sync module.
Oh, got it. It was Yehuda. Okay.
Yep. I think there are still other uses of stuff in that file in cloud tiering and maybe cloud sync. So it's not all unused, but at least user creation was just PubSub.
Mm-hmm.
Yeah, and
Yeah, this
PubSub
background
code
makes
is
more sense.
PubSub code is completely removed now. So
Got it. No, the Casey's background that Yehuda was the one that originally wrote this thing makes a lot more sense. Or makes sense.
All right. Shall we move on?
Yep.
All right. Moment of truth. Can I share my screen? All right. Are you guys seeing my Etherpad?
Yep.
Yep.
Can you guys still hear me? Do you see
Yep.
my screen?
Yeah.
Yep.
Great. Okay. All right. So this is just a first draft of an upgrade suite for RGW. All it currently uses is the ragweed test suite. And it basically starts by installing an older version of Ceph, runs ragweed prepare on an older version, then does some upgrades, and then runs the ragweed check step. So ragweed is basically just writing some objects during prepare and then checking that they can still be read after an upgrade. So there's only, it's kind of a 2x2 matrix. During the install step, we either install Pacific or Quincy. And then during the upgrade sequence, we either upgrade OSDs first or upgrade RGWs first. So it's really just running prepare before each step and a check after each step. This can uncover some upgrade issues, especially around uploads and multi-part uploads. But it's not a ton of test coverage. So I'd like to talk through some options, I guess. I feel like some kind of S3 test coverage would help, but our S3 tests are specific to a Ceph release. So I don't think that during an upgrade, we could really guarantee that either the previous test cases or the new test cases would all pass, right? Because sometimes we change test cases to fix bugs, and that bug is fixed on the new release, but not on the old one. So the test case is going to fail on one or the other.
Makes sense.
but I mean, I thought you're just interested in the new release, right? So you did some setup, you did the upgrade, and you run the test cases on the upgraded release and make sure that nothing is broken because of the upgrade. You don't care about the old release anymore, right?
The problem though is that S3 tests does a test fixture for every test. So you can't run the setup and then upgrade and then run the tests, right? It's all one self-contained thing. So you would do nothing, upgrade, and run the tests. And so all your testing is that the upgrade didn't completely break RGW.
Yeah, like we get testing of the current release from RGW Verify and other suites. So I'm not sure that it would be really testing anything interesting if we just run S3 tests at the end.
Is it testing that the upgrade didn't break RGW worthwhile though? Because in the other times we're testing S3 tests, it's a fresh Ceph cluster, not an upgraded one.
Yeah, that can cover some issues.
I mean, do you think it would cover interesting RGW issues, or would it only be testing the Rados cluster itself?
Yeah, I don't think it would test anything interesting in RGW because there wouldn't be any existing data from the old cluster.
Oh, but why? I mean, even if
because S3 test doesn't have a setup, right? Each individual test case sets its own thing up. And so in order to run a test, it sets it up, it runs it, and then it deletes it. And then the next test sets up, runs, and deletes. And then the next test sets up, runs, and deletes. So there's no setup stage we can run before we upgrade. The whole thing has to be run either before or after upgrade, or I guess during upgrade, but I don't know if that's even possible.
There are some parallel upgrade suites and other components that kind of do a rolling upgrade while a workload is running. So that's another option for us to have some kind of S3 workload going on that's not S3 tests. I think that's worth doing.
But that's different. This is testing the rolling upgrade, not the fact that we changed some configuration structure and we broke our configuration.
Well, but it would help because stuff would be being written to old RGWs and being accessed from new RGWs, right? And vice versa. And so it would test the compatibility code for the, accessing stuff. So I think that would help some at least. Right now, with just the S3 tests, we wouldn't be getting any compatibility code testing at all. We would need something that would have a setup and like the Tempest test, a setup, and then you can upgrade and then you can run.
Yeah, the ragweed tests
Sorry, ragweed.
needs specifically for this kind of upgrade testing. We haven't added any new test cases in years, but I think we should consider doing more.
What would running S3 in parallel look like? Would it just be you're writing some object from one and then making sure that you could get it back from an upgraded RGW? Or something along those lines?
We have tools for workload generation, things like CosBench and GaussBench and Warp
Mm-hmm.
that just do a workload of random reads and lists and writes,
Mm-hmm.
and it verifies that it can read back data that it wrote, and so that would give us some interesting test coverage. So you would just have that workload running in parallel while you're doing some upgrades in the background.
Mm-hmm.
Right. So the idea is that you would start the workload, it would be spread across all the RGWs, and then you would start one by one upgrading the RGWs, and the workload would continue to be spread across them all so that in transit, some of them are old and some of them are new, and by the end, they're all new.
Got it.
Okay, so I think something like that would be good to do in addition to this ragweed stuff in the existing PR. And maybe just running ragweed in this part is good enough. Adam, recently you've talked about using Warp for testing like this. Do you think that would be a good tool for an upgrade suite like this? Certainly don't want to touch Cosbench.
Yeah, I think so. I mean, I've used Warp for testing multi-site for the most part, just to get a bunch of objects and make sure they end up where they're supposed to. I don't know how much I would trust it for conformance or compliance testing, but I think it's good for smoke or workload testing.
Okay, yeah. Whatever we use, we definitely don't want it introducing false positives or errors that would happen even in normal operation.
Well,
And I guess it's worth mentioning that we also have a multi-site upgrade suite that runs multi-site tests in mixed version configurations. So it has like one zone on an old release and one zone on a new release. But multi-site tests aren't at all reliable, so there's not much point in running those currently. Any other ideas that you guys have for upgrade testing?
You mentioned the Tempest testing that are split into setup and test.
This is ragweed, not.
Oh, okay.
Yeah,
sorry.
sorry, I misspoke and said Tempest when I meant
Okay.
ragweed.
So I guess one thing that this PR doesn't cover is upgrading only one of the RGWs. It currently deploys two. It's only testing mixed versions between RGW and CLS.
Yeah, it seems like maybe what we want is, if we want more testing, we should extend the ragweed rather than maybe looking for other solutions. I mean, we may want a continuous workload test also. You're right about that. But it seems if we're going to add test cases, maybe we should just add them to the ragweed tests instead of trying to shoehorn in another test suite that isn't really appropriate.
Yeah, I think that's a good idea. Maybe we could start just with an audit of the test cases that are there. I know that there are a number of multi-part upload tests. When Yehuda added support for storage classes, he added test cases for that. But yeah, there's definitely more coverage that we could add there. But in terms of this PR, other than adding some kind of workload test, does this seem like a good just initial approach to get some upgrade test coverage?
Yeah.
Yeah. Just maybe a question about ragweed. Does it? I mean, does it assume the vstart cluster like the S3 tests, or does it have like a separate mechanism there?
Well, S3 test doesn't necessarily assume vstart. The config just points at an endpoint and sets up some access keys that you can configure, and the default config points at a vstart cluster. I would say that ragweed essentially works the same. The only main difference is that it also needs to be able to import the Rados Python module, because it can actually, inspect the underlying Rados layer to verify things,
Like,
which is
what
interesting.
what I'm thinking is that, just maybe as an exercise. I mean, I can take, let's say, I have this file that does all the bug identification tests, and like if you look at each and every test, like there's a section at the beginning where you do setup, and then there's a section later on where you actually run the test. I can split that into functions, and if I can import those tests from Ragreed, I can just execute them in 2 steps. But all the, it's not a lot, but there's some kind of underlying mechanics that assume that we have some kind of a cluster, and we have some functions that we can get the host name and the keys and all that stuff. So if that's going to be very complex, then maybe it's not a good idea. But if this is done in the same way, then it might be straightforward to do that.
So you're saying maybe converge some of the infrastructure between S3 tests and Ragweed so that test cases can be shared fairly easily?
Well, because there's a huge amount of tests in S3. Even in the specific notification suite, I have, I don't know, maybe 50 tests. Rewriting 50 tests would be lots of work.
Right.
And also, I mean, those tests, it's not only rewriting, it's like code duplication, which could be pretty difficult if, sometimes you have to, there are bugs and you have to change the test because you fix bugs or you add some new stuff. So keeping 2 sets of, if you talk about S3, this is like hundreds of tests in 2 separate places. That's not going to work. So I can, give it a try and see if this could be kind of easily done, also incrementally done, then maybe that could kind of actually fix the issue.
I mean, I don't know that Ragweed really needs full coverage of all the features, but we might look at kind of obvious things that might break over an upgrade, and try to have at least one thing that, creates a topic on an old version and make sure that it can still be used after an upgrade, things like that.
Yeah, everything that touches lots of metadata, but I mean, it's not only identification, it's also all the STS and IAM, all that stuff. I mean, it's all metadata that if we change the structure, then, we might break the upgrade. So, and sure, we don't need to cover all kind of, let's say, identification. We don't care if it's Kafka or MQP or whatever, because it doesn't matter. But even looking at S3 and all that stuff, there's quite a bit of tests that are doing exactly what it could break, like setting lots of metadata or kind of system objects and all that stuff. And those exactly are the places where we kind of suspect that things won't work.
So I think there's some overlap, but I don't necessarily think they all apply, because take, for example, lifecycle, right? For lifecycle, what we want to do is we want to set the lifecycle config, do an upgrade, and then check the lifecycle config to make sure it's the same. But in the S3 test, what we do is we set the lifecycle config, and then we do very complicated timed reading and writing and waiting and checking to make sure that the lifecycle is actually operating properly, right? And I'm not sure that that's necessary in an upgrade test, because what we're worried about is that you're right, the metadata was broken, right? And so all we need to do is read back the metadata and check that it's the same.
Well, but what if it's not the same but not broken? What if we change the code in a way that, so I tell what I did when I kind of did the cleanup to remove all pub/sub. I changed the structures. I removed a lot of metadata from the structures that was completely unnecessary, or is completely unnecessary in the new version, because we don't support pub/sub anymore, and we don't need this unnecessary information. So actually, I broke the structure, but in a way that the code should be able to handle.
Right. Well,
And
okay. So not necessarily the same, but expected. What's expected.
so I think the most reliable way to see that something is kind of what's expected is to let the code run and see that it functions.
Right. But my point is, in the case of lifecycle, you can't do that because it's really tight timing, and you can't stop and upgrade in the middle of it because you'll destroy all your timing.
Hmm. I guess. Well, what would we expect in real life when it comes to life cycle?
Well, in real life, lifecycle only runs once a day. Right. But in the debug testing, we're running it,
I
once a
see.
minute.
Hmm.
So it's probably worth mentioning that we do have some test coverage through the dencoder testing of our encoded formats. Essentially, each Ceph release, we compile a corpus of the existing object encodings. And in the new release, we test that we can decode the new version from the old stuff, which does help. But
Yeah, I mean that would find like exception saying, oh, but I mean if for example you decode and it says it's an old version and I don't support this version, then the decode is successful, right? I don't support this, but maybe this is not what you intended. And not only that, I mean you could decode successfully, but something is wrong with the values, and you have no way to do that. To know that, sorry.
well, I think the test does compare values insofar as it can.
No, I mean
Um,
if the logic of the code is different, then I mean it's not really the encoding and decoding that matters in many cases.
Right. Well, I mean, I think Dencoder does give us valuable coverage of just the formats themselves, but the
Right.
places where issues show up is where you're interoperating, for example, RGWs and CLSs of different encoding versions, where just protocol level stuff can show up errors where the encoding by itself doesn't.
Yeah.
So that's where I think the ragweed coverage of OSDs running different versions than RGWs is really useful, just to test the CLS stuff. But also I think testing mixed versions of RGWs. So, writing stuff on one RGW and verifying that you can still access it on another RGW running a different version could also be really useful.
That actually raises an interesting point. Just the separate OSD and RGW versions might be a good test case for S3 tests.
Yes, but still, I worry that we've written the test cases assuming that we have the fix from a fix that was in Reef for both RGW and OSD, and so if we're running a test case that assumes both, but in a mixed configuration, then it might fail, and we would kind of expect it to fail.
I would think that you would run the S3 test version from the RGW version that's being run, and that should generally succeed.
Well, what if the RGW fix relied on a fix in CLS also, and if you're running against an older OSD that doesn't have it, then it wouldn't pass.
Hmm.
I mean, you could potentially run the older version of S3 tests always, but I don't think that there's a configuration where we would guarantee that all of the test cases would succeed. So I mean, maybe we could start tagging things and whitelisting failures that we expect during upgrades, but I think that would get complicated, especially over several different releases.
This feels kind of exhaustive, but is it worth going through certain features we have and trying to figure out how we would expect them to operate during or after upgrades?
I mean, it's definitely worth thinking about that for new features that we're merging, and I try to incorporate that into a review. But you know, actually building test cases into Ragweed for specific stuff that we're adding, I think could help catch a lot of those kind of issues. It might not be as helpful to do that with old existing features that haven't changed over the releases that we're or haven't changed significantly over the releases that we're testing.
Yeah. The other thing I was going to ask is, do we know of any either downstream customers or upstream users that have had specific issues between upgrades that we haven't been testing?
Yeah, definitely. Probably not so much recently. I think we're doing a little better, but some kind of issues like that have come up with multi-site reshard. We kind of every time that we make changes to the CLS protocol, there's a risk of regressions like that. So I mainly just wanted to get a discussion started. I feel like this PR and its use of ragweed is a good start, but we should, you know, think about adding ragweed test cases for, you know, new development so that we can have better test coverage over these upgrades. Any other thoughts on this? All right, shall we call it here? Any other topics you guys want to cover in a few minutes? All right, thanks everybody.
Thanks you.